So let's look at one more example of solving a rational inequality. This time, my inequality, you can see, is here on the left, less than the number 2. So the first thing I have to do is gather all of my terms on the same side and set it greater than or equal to 0. And we're going to look at this one together because in order for me to do that, I'm going to have to add and subtract fractions. So, I'll give myself some room down here. What I have is x over x plus 2, and I'm going to subtract 2 to the left-hand side, and I'm setting that less than 0. Now I gave myself some room here because remember that when I add or subtract fractions, I have to have a common denominator. Well, the only denominator that I have here is x plus 2. So to this number here, we have to add a common denominator of x plus 2 over x plus 2. That's going to give me then this single denominator, x plus 2, because remember that when you add or subtract fractions, the denominator is going to stay the same. We're actually just adding or subtracting the numerators and sticking them over that common denominator of x plus 2. So the numerator is x minus 2 times x plus 2, less than 0. Simplify the numerator now just a little bit more. So I have x minus 2x minus 4 over x plus 2, or, we'll keep going down, negative x minus 4 over x plus 2 less than 0. Okay, I will caution you that when students move from this step here to this step here, they try to do this whole thing in their head and they forget that they are actually distributing a negative 2 to that second term. So they miss the sign down here on what it is that they're doing. So watch out for that. Now, this is the rational inequality that I want to talk about for the remainder of the question. To that, we are going to solve it to find the roots, and we're going to find its asymptotes. Remember, when we find the roots, we take the rational function, negative x minus 4 over x plus 2, and set it equal to 0. And I got to give myself a little bit of room here. I'll pull that down. Okay, so if I am setting this thing equal to 0, I would multiply both sides by the denominator. That's going to just leave me negative x minus 4 equals 0. Or if I add x to this side, I get 4 is equal to x. This is where we are crossing the x-axis. Now how about the vertical asymptote? Vertical asymptotes were where the denominator is equal to 0. X plus 2 equals 0. So I have a vertical asymptote at x is equal to negative 2. These are my roots, or this is my root, and this is my asymptote. Those are the two numbers that I'm going to put on my number line. Okay, so I have negative 4 and a negative 2. Now, I'm going to bring down my inequality that we're looking at again. It's negative x minus 4 over x plus 2, and we're solving for where it's less than 0. Not less than or equal to, just less than 0. So even though this negative 4 is a root to my function, I can't include negative 4 because the symbol doesn't allow me to right here. So this would simply be from negative infinity to negative 4 with a parentheses because I can't include negative 4 in the solution. In the center, we would be at negative 4 to negative 2 parentheses. Now the reason this is a parentheses is because I have an asymptote occurring at negative 2, so I could never include it no matter what. To the right, we have negative 2 to infinity. Now we're going to pick our test points. So to the left of negative 4, I'm going to pick negative 5. In the center, I can only pick negative 3 if I want integer values. And to the right, I'm going to pick 0. when you evaluate the function at each of these points, right? So I'm going to evaluate at -5, -3, and 0. These are just the values I picked. You find out that your function, when you plug it in, you get a negative value here, a positive value in the center, and a negative value on the right. Now my function is asking me for where my function is, or where the inequality is less than 0. So that is occurring at these negative values, which are on the ends. So my solution set is going to look like from -infinity to -4, union -2 to infinity. And I would draw the interval, I would draw the graph to look the same. -4, -2. I have parentheses. I'm going to shade, and that's what my solution set would look like when it was graphed. So although I didn't come in and explicitly show you that if I plug in -5 over here into the function, I want to make sure that you can do that on your own and still come out with, when I plug in -5, you should come out with some negative value. I believe it's -1/3, but it's still a negative value. And that's how we're going to do it when you have to gather all of your numbers or your values up on the same side to go through and graph and solve this rational inequality.